Good afternoon. Today we're going to talk about the midsegment theorem and the coordinate proof, which is section 5.1 of our textbook. So first we're going to go ahead and define the midsegment of a triangle. The midsegment of a triangle is a segment that connects the midpoints of two sides of the triangle. So what that means is I have triangle, could have ABC here, and then I go ahead and I take the midpoint of AB, which means that I'm going to call it D here, AD is congruent to DB. I'm going to take the midpoint of BC, I'm going to call it E, BE is congruent to EC, and I'm going to connect them. The midsegment is this connection piece right here. It's the segment that connects the midpoints. That's the midsegment. It doesn't have to be just this orientation. I could have a triangle, same triangle. I could take it from these two sides here, and you'd still have your congruence of it separates it by congruence. Because that's what the midpoint does. It makes the two pieces congruent when it's at its midpoint. I'm going to jump down to 5.1 midsegment theorem. The midsegment theorem says that this segment that we just defined, connecting the midpoint of the two sides of the triangle, is parallel to the third side and is half as long as the side. So what this is saying right here is that now, because I have that midsegment, those two pieces are parallel, and that my midsegment is half my total length. Half my total length. So the midsegment equals 1/2 my total length. So now, the coordinate proof. The coordinate proof just involves placing a geometric figure in a coordinate plane. Now, when you're talking about placing a figure in a coordinate plane, so first, here's my X and here's my Y. You're going to want to place it so you have an easy reference point. What does that mean? Use the origin. So I'm always going to want to use the origin as one of my reference places. So whatever I am doing, if I have a square or a rectangle or whatever, I'm going to want to place it where one of the sides is here, and if I can get other sides here, I can, because I always know there are other points. Like here, because it's on the Y, I know my X value is 0, I just have to find a Y value. Because I know this is on my X, I don't know my X value, but I know my Y value is 0. So you want to go ahead, and we'll talk about actually how to set that up with the different variables and stuff in just a moment. But when you're looking at it, place it on the coordinate grid to where you can get points you know that are easy, like the zeros, okay? And we'll talk about that when we do our example. So now let's talk examples. Number 1 tells me a large triangular window is segmented as shown. In the diagram, DF and EF are midsegments of triangle ABC. So if DF is a midsegment, then I know that if DF is the midsegment, it cuts AD to be congruent to DB, and it cuts AF to be congruent to FC. Then it tells me that EF is also a midsegment. If EF is a midsegment this way, it means that it cuts BC where BE is congruent to EC. The reason I use 3 tick marks is because it was already used 1 and 2 earlier. Then I know that AC is also cut because that midsegment, but I've already demonstrated that AF is congruent to AC, so I don't have to put any markings on that. It already works from the other one. So now I want to go ahead and find DF. DF is the length of my midsegment. We know that the length of the midsegment equals 1/2 of the length of the segment that is that third side, which here in this case is BC. We know that BC is 90 inches. So DF equals 1/2 of 90. So DF is 45, and because it's inches, we'll put the appropriate label on it as inches. Now we want to go ahead and find AB. We know that AB is the side that is opposite of that midsegment EF. So again, we know that the midsegment EF is 1/2 of the length of AB. That's what the theorem tells us. We know that EF is 45. We're trying to find AB. So, a little bit of algebra. And label my answers. Now it says on B, what is the length of the midsegment opposite of DF? The midsegment opposite of DF is this little tiny segment right here that's not listed. That's the midsegment opposite of DF. It's cutting my triangle again. So what's the length of that midsegment? We're going to go call it, we can call it GH, or we can just call it the midsegment opposite of DF. So the midsegment equals, so the midsegment opposite of DF equals 1/2 of whatever DF is. We already found out that DF above here was 45. So we know that, I'm going to call this just X to make it easier. X equals 1/2 of DF, which is 45. So X now equals 22.5, and again it's inches. But it's the midsegment opposite of DF. I just made it easier looking. All right, number 2 says, in the diagram, QS equals SP. So I'm going to go ahead and I'm going to mark right away. QS equals SP. We know that PT is equal to TR. Show that QR is parallel to ST. So I'm trying to prove here that QR is parallel to ST. So, this piece here is parallel to this piece here. Well, we know by we know that because they are given, it's given that they're equal. We know that from what is given, as in any proof, and we're not having to use the proof, but we know that here, we know that S is the midpoint of QP. We know that V is the midpoint of QR. And because they're both mid-segment, we know that they're both midpoints. We know that ST, the line, is the mid-segment, because it connects the two, of this triangle QPPR. So therefore, by the theorem 5.1, well, actually not by theorem 5.1, because you're proving theorem 5.1. So then, because they're by the definition of mid-segment, then they're parallel. So it actually is just theorem 5.1. Tells you that they're parallel if one is half the length of the other, which because of the two being parallel, it would be. So, so they're parallel by that mid-segment theorem. So by theorem 5.1, ST is parallel to QR. Okay, if part B says if V is the midpoint of QR, what do you know about SV? Well, if if V is the midpoint of QR, then we know that SV is a mid-segment and that QV is parallel to PR. Because we know that if this is a midpoint right here, then we know that this segment is congruent to this segment. So therefore, we know that SV is going to be parallel to, to PR. Sorry, I got my letters mixed up. SV is going to be parallel to PR based on the fact that SV is now a mid-segment. Questions about that? All right, then let's talk about the coordinate proof. The coordinate proof, it's just kind of weird, so you got to understand algebra is basically what happens with this coordinate proof. It says to place each figure on a coordinate in a way that is convenient for finding side length and assign coordinates to each vertex. So, when you talk about it being convenient, we want to use as much zero power as possible. So, I'm going to want to take my square. Well, first of all, what do we know about a square? A square has 4 congruent sides. That's going to become important when we're talking about placing it here. So you're always going to want to place a vertex at the origin. So I'm going to place a vertex at the origin. Because it's a square, the rest kind of follows in place like this. I wouldn't put it in some way, and I want to keep everything in quadrant 1 if possible. Why? Because it's all whole numbers. So keep things in quadrant 1 so everything is positive. So now if I'm trying to assign vertices or coordinates, well, first of all, I know looking here at my y-axis, I know that here, if x is my side length, then however long my side is how far I went up that axis. And we know with a square that they're all the same. So here, when I'm talking about my x-axis, I know that however far I've gone here is the side length, and I'm at 0 because I'm not going to go up and down. So now, how do I determine this point over here? Well, it's where my x and my y come together. It means I went this far out, I went this far out, I went this far up. So here, the ordered pair is just the way I went this far up and I went this far out because all 4 sides are the same. So now my side is just x and x. It's just understanding when you're placing it on, what does it mean? It's not meant to be tricky. I just want you to think. So I'm going to go ahead and set up this next one. Here's a coordinate grid. It says I want an acute triangle. All right, so what do we know about an acute triangle? 1, 3 different length sides. Which means if I have 3 different length sides, I might end up having to have 3 different variables. Can I place it right here at the origin? Can I make my triangle come across like, I'm going to use a paper clip, like this? No, because that would give me a right angle. And with an acute triangle, all angles are less than 90 degrees. So I can't place it in the best way possible. So I'm going to have to kind of draw it like this to make it all acute. All right, here's where we have to think again. First of all, I'm going to go ahead and do this point first because he's on that axis. If I don't know how long this side is, I'm just going to call it A. Then the length of this side makes the ordered pair, A, comma, 0. That's an A, sorry. A, comma, 0. Got carried away with my A there, I apologize. Now, to try to find this right here, we know this ordered pair here is how tall he is, because that's going to be where that comes from. It's how tall he went up and how high he went up. So if we call his height B, how tall he is, then we know that this point here, is going to be how tall he is my Y value, so that's going to be B. I kind of put it in a weird place. Sorry about that. It's going to be B. But I don't know where he is on this line. He doesn't cut it in half. So again, I'm going to have to say, all right, what point am I at here? Well, I'm going to have to make up a point C. He's at whatever C is up to B. So if C is right at that little mark there, because A is that whole distance, is A, C is just that point right there, then that ordered pair is CB. It's just understanding how ordered pairs work. It's not meant to drive you crazy. It's just understanding how ordered pairs work. And how they have to be different lengths, they have to be different variables, because each different length would have to be a different variable. If they were the same length, like we did in our first one, then we can use that same variable x because everybody's all the same size. And don't get crazy. Just try to place it at the origin and think about how the sides are going to be. It's how do the sides pan out. Make up numbers to help you if you need to. All right, on number 4, it says to find the length and the midpoint of the diagonal of the square in number 3. All right, so first, the diagonal. Let me use a different color, sorry. This is a diagonal of number 3. Doesn't matter which one you choose. I just chose that one. It doesn't matter. Probably would have been easier to do the other one, but we'll see mathematically if I've just totally messed up my whole world, because using 0, 0 would have been a better point. So, yeah, let's use the point 0, 0. I'm going to do a different color. Let's use the point 0, 0, because that's going to make math much easier trying to find my midpoint. So let's draw it this way instead. We could do it the other way, but it's going to make life a little trickier with our mathematics, but we're super smart, so it's no big deal. We could always handle it. All right, so what I know about this, I've labeled all my points up there. I know first I want to find the length, which means my distance, our famous, happy distance formula. But now your distance formula is going to be weird, because why? I'm not going to have numbers. Okay, this is where your super smartness comes in. We know that distance equals the difference in my x's squared plus the difference in my y values squared. All right, so up here, I'm going to take the point 0, 0 and the point x, x. Okay, so now, the difference in my x is squared. So I'm going to have 0 minus x squared plus the difference in my y squared. 0 minus x squared. Just because it's the y value, it's still the number x, okay? When I clean this up, I have negative x squared, or negative x squared, and I have negative x squared. So negative x squared is going to be positive x squared, because negative 1 times negative 1 is positive, plus x squared. All right, but if I put it together, just combine like terms. All right, now you remember, if I strung this all out, to get out of the house, because it's a square root, it takes 2. That is my simplified answer. I can't do anything else with that problem. That's my simplified answer. That is it. Sorry, I went off the video. I apologize about that. So it takes, sorry, I'll just repeat what I said because I didn't realize it was off the video. So here, my x squared, I just strung it out. Takes 2 to get outside of my house, so I'm left with 2 square roots of 2. Now I have my midpoint. We know my midpoint formula says I'm going to add my x1 plus my x2 and divide by 2. I'm going to add my y1 and my y2 and divide by 2. So now, coming up to my same point, 0 plus x divided by 2, 0 plus x divided by 2, using my same ordered pairs from above, which were, in case you were not sure. So now when I simplify, it's just x over 2 and x over 2. That's my midpoint. Can't be anything else. It's just understanding if they ask you to take the distance, you're going to be using variables. So you're going to be able to do this, you're going to be squaring and doing all the stuff you had to do with variables. Not hard, it's just a different abstract way of thinking. That's it. Different abstract way of thinking. Thank you, and if you have any questions, of course, we'll address them in class. Have a great Thanksgiving.